Hey guys, welcome to my face. So we need to take notes today on some membrane transport things. And so we're just gonna have to do the notes like this. We did this earlier in the year when we did water and it worked pretty decently. So I believe in us. But yeah, also I know that some of you in 8th hour, I still have your notebooks. I'm actually using them right now to prop my computer up so that it's high enough that I can talk into it, which is super fun. But best you can take notes on this because I will be doing notebook grade. If I have your notebook, I guess just blank piece of paper, we can tape it into your notebook. I'm sorry, I don't really know what to do about that. My bad. But today we are going to continue to talk about the membrane of a cell, and we're going to specifically talk about the different kinds of transport, the two easy kinds of transport through that cell membrane. So let me get smaller and we will get into it. Let me move over here actually. There we go. All right, so we're talking about membrane transport today. When we left off the other day, we were kind of teasing around the term that we're going to start with today, which is diffusion. Okay, so these are probably some things that you've seen before. I know that the FACS teachers, Miss Dixon, for sure has one of these behind her desk, and she puts like smelly stuff in it, and it makes the room smell really nice. A lot of you may have these things in your cars that make your car smell really nice. They clip into your vents, or these things that plug into the wall. These things are all pretty much the same kind of device, and they're called diffusers. Okay, so the word diffusion just means to spread out. Okay, so that's what these devices are doing, is it's taking that concentrated smell and it is spreading it out over the whole room. So diffusion is just the spreading out of something. So on the left here, we have a GIF of somebody dropping like some like food coloring into a glass of water. And if we let that sit, all of that food coloring will eventually diffuse or spread out to fill that glass of water. Over here on the right, we have a GIF of this happening with gas. So if you like have a small pocket of gas right here, it will diffuse out into the whole space and it will kind of spread out evenly. That's why if your buddy across the classroom farts, you'll smell it eventually because those gas particles will diffuse out and fill the room. Okay, so we were kind of playing around with the ideas of diffusion on Friday as we, talked about things moving through a membrane. But a really great example of this is if I had a bathtub and for some magical reason, I was able to insert this like plexiglass barrier in the center and I filled this side of the bathtub up with water. Okay, this side of the bathtub has a lot of water in it. It has a high concentration of water. This side of the bathtub does not have a lot of water in it, so it has a low concentration of water, okay? Now, if I were to remove this weird divider thingy, it would even out, okay? The water would go from being all on this side, it wouldn't stay like it is, because if I moved this, it would even itself back out. So the fancy way of saying what is happening here, which is a very simple concept, is that molecules will move from high concentrations to low concentrations. Okay? And again, that just means that things will even out if they're allowed to. Okay? So our fancy definition for diffusion and our science definition for diffusion is the movement of molecules from high concentrations to low concentrations. So if we look at this situation over here, we have right here a very high concentration of purple circles. And on this side of the barrier, we have a low concentration of purple circles. If you let these guys sit and just go about their business, over time, you'll get a relatively equal amount of purple circles on either side. They will move from high concentration to low concentration until they've pretty much equaled out. Okay, so that's basically what our first type of movement around the membrane is simple diffusion. So it is diffusion, it is simply diffusion. okay? So molecules move from a high concentration to a low concentration. Oh no, I didn't say it. It should also say across a membrane. Okay, so molecules move from a high concentration to a low concentration across a membrane. So a really great example of simple diffusion is if you take a deep breath, you have a lot of air that's now in your lungs, and that air has oxygen in it. Oxygen in that air is in a higher concentration, so it will diffuse into the blood that's in your lungs. Not like in your lungs, but like that's in the cells and in the blood vessels that are in your lungs. Not like you actually have like a bucket of blood in your lungs. That's gross. Coronavirus, who knows? But that's a really great example of diffusion, where things are going from a high concentration, the air, to a low concentration, the blood that is in the vessels in your lungs. Okay. Since it is just a simple diffusion and these molecules will do it on their own, it doesn't require energy. We don't need any ATP to get this situation going. It's just going to happen on its own. Now, we talked on Friday about the way that a cell membrane looks. So we have this phospholipid bilayer here, 2 layers, a top and a bottom, of these phospholipids. Now, this middle part is the lipid part, which means that it is fat, which means that it is nonpolar. So if something just wants to diffuse straight through this membrane, like these red molecules are doing right now, it means that they have to be okay hanging out in this fatty nonpolar layer. So the only kinds of molecules that are okay with that are small nonpolar molecules. So that is what we are diffusing simply through the membrane. Okay, just really small, nonpolar, things that are okay with hanging out with fat molecules. Okay, so going back to this diagram that we talked about on Friday a little bit, we have this big molecule right here. And bless his heart, just too big. Never going to be able to diffuse through this membrane. It's just not going to happen. Okay, these little guys are going to be able to simply diffuse through this membrane. Now this red circle here, I had some classes that were like, maybe it could go through. I mean, it would kind of have to like really get in there, but he could maybe squeeze his way in through here. And that's true. But if you were to like force this guy through here, it would probably pop. It's kind of like, it's very much like an airtight balloon, the cell membranes are. But what if we really, really need this molecule to be on the inside? Or what if this molecule specifically is like water? Like water is extremely important to us being alive, but water molecules can't simply diffuse because they're not okay with this big waterproof layer of fat. So we have to have some other way to move things past the membrane. It can't just be simple diffusion like these little black circles will do. So we said that simple diffusion, we said that the membrane a million years ago, we said the membrane was made of phospholipids and proteins. And we talked about the phospholipids, which is these little circles with tails. We haven't talked yet about the proteins. So what if we had basically like a tube in the membrane? Okay, this guy could then go through, okay? And that is exactly what the proteins in the membrane are. There's 2 types of proteins in the membrane. There's like transmembrane proteins and surface proteins, and you're gonna get into that a little more on your worksheet today. But basically you have simple diffusion, which is these guys, and then you have facilitated diffusion, which is just diffusion with help. That's what facilitated means. It means to help. So we are moving from high concentration to low concentration. We're just doing diffusion, but we're doing it through a protein tube. Okay, so you can see that happening over here. We start with a really high concentration of blue circles and a low concentration, and they're going to move from high to low until they even out. Okay, so we are just doing regular diffusion through a tube. We're getting some help. We're using a protein tube. Okay, now because this is still just diffusion, it does not require energy. Okay, you don't need to make this happen. It will just happen on its own. And we still have to be small molecules. So if this was, if we had that big blue molecule here again, it doesn't really matter what's going to happen. He can't fit through this little hole. Okay, like he can't fit through this little tube. It's just not going to happen. Okay, this giant blue molecule just needs to figure something else out because he's not getting in. So we still have to be small enough to fit through, and these tubes really do look like straws. So they have to be small enough to fit through. They also are going to be polar. Okay, so this is a polar molecule that normally would not be okay going through this big non-polar chunk in the middle here. Okay, so those are our two types for now. There are 5 ways in total, but we'll get to those later. But for now, we have those 2 ways of moving things from outside of the cell inside. So, that cheeseburger that you ate for lunch, you digested it and put it into your blood, and now we need to get it into the cells of your brain so that you can breathe and function and stuff. Well, we're going to do simple diffusion to pull those molecules from outside in. Or, you drank a glass of water just now. We need to get those water molecules into your cells. We're going to do facilitated diffusion to pull them out of your blood and into your tissues. Okay, so those are your 2 types of diffusion: simple diffusion and facilitated diffusion. Neither of them require energy. They just do it on their own, and they're going from high concentrations to low concentrations. Okay, all right, cool. Bye, guys.